Today we are going to discuss a new topic. It is called Lebesgue Measurable Set. Lebesgue Measurable Set. Okay. So, what is Lebesgue Measurable Set? A set A is a subset of R is said to be Lebesgue measurable if there is a Borel set B in A such that A difference B outer measure is 0. Now based on this definition, we are going to go and prove a very important proposition. So that proposition is a set A is subset of R is Lebesgue measurable if and only if for every epsilon greater than to 0 there is a closed set F in A such that A difference F is outer measure is less than epsilon. So proof, first of all, this way. So definitely we are gonna let epsilon greater than to 0. So suppose our supposition is, suppose A is Lebesgue measurable. What does this mean by definition? Then there is a Borel set B in A such that A difference B outer measure is 0. What we need to show that there is a closed set F in A such that A difference F is less than epsilon. That's very easy to show. So why? Now since B is Borel, so there exists a closed set F in B while B is contained in A such that B difference F is less than epsilon. That's well established result. You should know whenever we have Borel set, there will be always a closed set such that B difference F is less than epsilon. Now, but our goal is, again, we need to remind our goal is, again, I want to remind you, their goal is somehow show that A difference F outer measure is less than epsilon. This is our goal. Now to accomplish this goal, what we are going to do, we are going to use a Venn diagram so that you can have a better understanding. So this is my superset. We have 3 set, and this is my another set, and this is my another set. So this superset, suppose we have this is A, and then we have B, and then F is the smallest. So what do you think about this whole region, this region? So this region says this is A difference F. Now I'm gonna use different color. What do you think about this region? So this region, I would say that this is, what is this region? A difference B, right? And then we have another region which is called this one. Okay, this one. So what is this region? This region is B difference F. Now what do you think about this red region? What do you think about this whole region? How can we rewrite? So this region can be written as A difference F is definitely, so this is this region and this region. So combination of these two regions. So this region is nothing but we saw it was A difference B, and then union this region was B difference F. Okay, so A difference F is A difference B union B difference F. Now we're gonna go, and so if we take this is less than, what A difference B outer measure plus B difference F outer measure. If you don't know how this is lesser or equal to, so if we take the outer measure A difference F, this will be A difference B union B difference F outer whole measure. But we always know that no matter what, A union B outer measure is less than or equal to outer measure of A plus outer measure of B. So that's what we have. A difference F outer measure less than or equal to A difference B outer measure plus B difference F. Okay, that's easy. Now what is outer measure A difference B? It was 0. Why? Because A was Lebesgue measurable. So 0 plus B difference F. But what is B difference F? This is this. So this is less than epsilon. And we accomplished our goal. That was A difference F is less than epsilon. Just based on this Venn diagram. Okay, I hope you understand. Now we're gonna prove converse. So converse our goal. So converse. Now what is our supposition? So supposition is that for every epsilon there is a closed set. But now instead of epsilon I'm gonna use n. Okay, later on you will understand why. So I would say our supposition is that there is a closed set Fn containing A such that A difference F and outer measure is less than 1 over n for all n belong to n. Okay, now our goal is, what is our need to show? So need to show A is Lebesgue measurable set. That is, there exists a Borel set in A such that A difference B outer measure is less than 0. So what we just need a Borel set first, and then A difference B outer measure is 0. So how we're gonna come up with a Borel set? So since Fn is a closed set, and we know that the countable union of closed set is a Borel set, so we can say that. So I'm gonna use a different color so that you can understand. So let B is nothing but union of n is equal to 1 up to infinity Fn. Then it is a Borel set. Why? Because countable union of closed set is a Borel set. So if we have a Borel set, now we got the Borel set. Now we just need to show A difference B outer measure is 0. So if this is a Borel set, what we can do then, A difference B is actually A difference union of n is equal to 1 up to infinity Fn, and definitely this is contained in A difference. I'm gonna use different, and this is Fk. Okay, now so if we have everything, okay, so I would say for all k belong to n. Now this is A difference B outer measure is actually A difference union of n is equal to 1 up to n of outer measure, but this, since this is a subset of A difference Fk, so this means that this outer measure is less than or equal to A difference Fk outer measure. Okay, so but A difference Fk outer measure is over here, this is less than 1 divided by k. Okay, so A difference B. Now let k approaches to 0, up to infinity, then sorry, infinity, I thought it was epsilon, so definitely it is infinity. Then what do you think about A difference B outer measure? This is 0. Hence we got the result, and we got our goal. Thank you, and I hope you understand it. I explained it very well. This is my understanding, but I don't know, but I hope you will like it. And thanks.